It's time now to pretty much totally change gears, and we want to start working with the idea of sequences and series. So let's start off with an introduction to sequences. By definition, a sequence is a function whose domain is a set of positive integers. As example, 1, 2, 3, yada, 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 out to infinity is a sequence of positive integers. Notation-wise, we very commonly use something like the sequence an, where the sequence is a and n is a subscript, where n equals 1, 2, 3, out to infinity. And often we start n at 0, so we may go from 0 to infinity. But an would then be this sequence 1, 2, 3, and so forth, which means that a1 equals 1, a2 equals 2, a3 equals 3, and so forth. This example here, the sequence bn, b1 equals 1, b2 equals 4, b3 equals 9, but I can represent this in terms of n. In reality, b1 I can think of as being 1 over 1. b2 is 4, but you know what? I'm going to work with this 2, so I'm going to put a 2 there and square it. Let's see, b3 is 9, but that looks to me like 9 is actually 3 squares, so this is 3 squared. So, 1 over 1 may not be a good choice here. This may actually simply be 1 squared. That will still give me the 1. Now what I have is this pattern that looks like there's an obvious pattern here, so forth and etc. So what it appears to be is that bn is actually equal to n squared. Now, using this type of idea, I can come back up here and say, well, you know what? an is actually equal to n. So now I have both of these sequences, an and bn, defined in terms of n. So if I want to know up here what a27 was, well, clearly that's just 27. Down here, if I want to know what b27 is, well, that's 27 squared. So these are two examples of some pretty simple sequences. This next sequence, the Fibonacci sequence, is a very, very famous sequence. It essentially goes like this. It's 0, 1, 1, 2, 3, 5, 8, 13, 21, and the pattern continues. The question is, did you pick up what the pattern is? The Fibonacci sequence is an example of a recurrence relationship. In other words, each of these values depends on a previous value. So I'm going to start off with the idea that a0, this time I'm going to start off with 0 equals 0, a1 equals 1, a2 equals a1 plus a0, which equals 1, a3 equals a2 plus a1, which equals 1 plus 1, which is 2. Oops, that's supposed to be an a. a4 equals a3 plus a2, which equals 2 plus 1, which equals 3. So you can see what's happening here. I have 0, 1. Basically, I started off with these two values, and then from there, I started adding the previous values. So once I have this set up, I can actually say that an is equal to an minus 1 plus an minus 2. It's the addition of the previous two values. And you can see how these values match up with the sequence that I wrote here. And just to make sure, because I wrote that kind of big, make sure you don't misunderstand. This was subscripts. This is an n minus 2 in the subscript. So it's not an quantity minus 2. It's which of these an's I'm working with.